Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we're going to start with chapter 16, polar coordinates and convex numbers. We have already learned about vectors, how to get the vertical component, the horizontal component, how you could represent it in a coordinate plane by x and y. We have another type of coordinate, we call it polar coordinate. And in this type of coordinate, we're gonna consider the origin point as the center of a circle. And you are drawing circles with 1 unit. We call this unit circle. Then here 2 units, 3 units, 4 units, and so on. So this means that the distance, if you have a point like this one, the distance between the origin point and this point would be the radius. And you remember that the vector is just making an angle with the x-axis, right? Here this is theta. And here also it would make an angle with the x-axis, which call it theta. But in this case, I'm gonna say that the x-axis is called polar axis. As you see here, we are measuring the circle with degrees. Now, each line represents 15 degrees, 15, 30, and 45. So if my point is here, so I'm gonna say how many circles you have here? 1, 2, 3, 4, 5. So this is 5 and 45. I could represent it by r and theta. So in polar coordinate, we represent the point by r and theta. The r is the distance from the origin point, and the theta is the angle which the vector make it with the polar axis or the x-axis. So I could represent the point by the x and y, or I could represent it by r and theta in the polar coordinate. And of course, you have many representation for the polar point here. You could add for theta a full rotation 360 or subtract a full rotation 360. Or you could flip the direction of the radius and add to the theta 180 or you subtract 180 or its multiple. And it has to be odd multiple, which means what is the odd multiple of 180? It would be 540, 180 times 3, 180 times 5, 180 times 7, and so on. But for 360, you're going to add the even multiple, so 360, 720, and so on. 360 just only one rotation, 720, two rotation, and so on. So I could represent the polar point here with many representation. Maybe I keep the direction of the radius, but I'm going to add a full rotation or subtract a full rotation and its multiples from theta, or I could flip the direction of the r and add for subtract from theta 180 or its odd multiple. Let me give you an example here. Let me apply this rule over this point here. So I could add or subtract 360. So it would be here 2 and 30 plus 360 give me 390. Or I could subtract 360 minus 30. So 30 minus 360, it would be negative 330. This is also another representation for the same point. Maybe I will flip the direction of the radius, so I will make it negative 2, and add 180. So 30 plus 180 give me 210. Or I could subtract 180, so it would be negative 2 and negative 150. So all of these are just the same representation for the same point, 2 and 30, in the polar coordinate. Another rule that you should know the distance between 2 points. Here is the rule for it. Let me give you an example to understand how to apply the rule. We have here 2 points, P1 and P2. Here's R and here's theta 1, R1, R2, and theta 2. Now let's apply the rule. So here it would be negative 3 power 2 plus 4 power 2 minus 2 times negative 3 times 4 cosine theta 1 minus theta 2. And actually, it doesn't matter if you flip theta 2 minus theta 1, it's still the same. So here, 240 minus 60. Okay, so negative 3 power 2, 9, 4 power 2, 16. 2 times negative 3 is negative 6. Negative 6 times 4 give me negative 24. And cosine 240 minus 60, it's cosine 180. Cosine 180 is negative 2. Sorry, negative 1. So here it would be negative 24 times negative 1. So here the square root of 25 minus 24. So it's the square root of 1. So the answer is 1. Now you need to know how to convert between the polar coordinates and the Cartesian coordinates. So if I have r and theta and I need to change it to x and y, the Cartesian, so I know that from the vectors that x equal or cosine theta. And I know also that the y equal r sine theta. And I already have the r and I already have the cosine. So I could get it so easily. But if I want to convert from the Cartesian to the polar coordinates, this means I have to get the r, then get the theta. Now, how I got the r? Of course, you remember the magnitude of r, just taking the square root of it, x power 2 plus y power 2. So I get the r. How could I get the theta? You remember the tan? So theta, I could get it by tan theta. But remember, if the x was greater than 0, I will just leave it. The angle is the same. But if x is smaller than 0, I have to add to theta 180. You remember this rule? So easy. Let's try an example to apply on it. Now I have 5 and pi over 3. Now, this one is polar or Cartesian? Of course, this one is polar. R and theta. And I need to convert it to Cartesian. So x equal r cosine theta. R is 5. And theta over pi over 3 means 180 over 3, which is 60. So it's cosine 60. Y equal r sine theta. So it's 5 sine 60. Now cosine 60 is half. So it's 5 times half. So it's 5 over 2. And sine 60 is root 3 over 2. So it would be 5 root 3 over 2. So now I convert it to 5 over 2 and 5 root 3 over 2. Let's take an example how to convert from Cartesian to polar. I have 1 and root 3, x and y, and I need to convert it to polar. So first I have to get the r. So 1 power 2 plus root 3 power 2. So it's 1 plus 3 give me root 4, which is 2. So I got the r. Now I need the tan, or the inverse tan of theta. So it's y over x. So tan inverse theta equal y over x root 3 over 1. Do you remember what is the angle that have tan equal to root 3? Which is so theta is 60. Now I have the r. Now I have the theta, so it's 2 and 60. Here's it. So easy and so simple. Just you have to practice the rule, and you're gonna memorize the rule if you practice it more than one time. Now let's try to solve some problem over the part that we have discussed before. The polar coordinate for point A, shown in the adjacent figure, here's point A, in which circle 1, 2, 3, and which line is here is 225. So it's 3 and 225. Here's it. 1, 2, 3. All of the following points represent the same location as points 3 and 240 in the polar coordinate plane, except. So let's try the choices here. Or you could try the point itself, but it's favorable to try the choices. Now let's see here, negative 3 and 60. He flips the direction of the radius. So this means I could add 180 or subtract 180. So if I add 180 here, give me negative 3 and 240. It's the same. Now here, 3 and negative 120. The R is positive, so I could add 360 or subtract 360. So if I added 360, give me also 240. Still the same. Now, negative 3 and negative 300. Negative 3, he flipped the direction of radius, so he added 180 or its multiple. And because it's greater than 180, I'm gonna add 540, which is the odd multiple of 180. So it would be negative 3 and negative 300 plus 540 will give me also 240. So all of them is still the same. Now this one, 3 and 60, actually, this one is the first quadrant and this one is the third quadrant. So obviously it's not the same. So here's my answer. Now we'll go for question 3, the distance between the 2 points. I have 2 points and I have to apply the formula for the distance. Let me remind you with it. Take the square root, a big square root. R1 squared plus R2 squared minus 2R1 R2 cosine theta 1 minus theta 2. Let's apply the rule. So here is it, 25 plus 16. 2 times 4 times negative 5 give me negative 20. And cosine 180, negative 180 give me negative 1. So this would be negative 1. And this would be negative 20. So negative 20 times negative 1 give me positive 20. And here's minus. So here's 20. So root 41 minus 20. Sorry, it's 40, not 20. 40. So it would be here 41 minus 40. So it's square root of 1. It gives me 1 unit. If the polar coordinate of point P are 6 and y over 4, then the Cartesian coordinate. Okay, let's apply the rule. X equal r cosine theta and y equal r sine theta. So it's 6 times cosine. Pi over 4 means 45 cosine 45. So it's 6 times root 2 over 2. So give me 3 root 2. The same here, 6 times sine 45, and sine 45 is the same, so 6 times root 2 over 2 give me 3 root 2. So my answer, choice A. Question number 5, one of the polar coordinate of the point negative 1 and negative square root 3 in the Cartesian plane. Actually, this one is. So here, let's try to apply the rule. The R square root of 1 power 2 plus negative root 3 power 2. It gives me the square root of 4, which is 2. I got the R. Now let's get the inverse tan theta y over x. So negative root 3 over 1. Give me negative. So it's which one has the negative root 3 as a tan? So it's here theta equal 120. So it's 2 and 120. So theta here is 120. So 2 and 120. The polar equation theta equal pi over 3 is equivalent in Cartesian coordinate too. Okay. Theta equal pi over 3, which means it's 60. So theta equals 60. And I know that the tan theta equal y over x, right? So if I need to isolate the y, I will just do cross multiplication. So y equal x times tan theta, which is tan 60. Now tan 60 is root 3, so y equal root 3x. A polar equation R equal 4 represents R means the radius, so a circle with a radius 4. The Cartesian equation x power 2 equal 4 in polar coordinate is. Okay, let's see here. X equal R cosine theta, right? We know this. R cosine theta, but here it's squared, so I have to square them. And y equal R sine theta. And I just need to isolate the R, so this means I have to isolate it to divide by R for each side. So here it would be R cosine square theta equals sine theta. Good. Now let's divide again by cosine the square theta. So R equal sine theta over cosine the square theta. You remember that the secant is just about 1 over cosine. So this means that secant square, it's just only 1 over cosine square theta. So this means it's just only sine theta multiplied by secant square theta. Question number 9. What is the polar form of the equation x power 2 plus y plus 3 power 2 equal 9? Let's first simplify it. X power 2, this is the perfect square, so let's factorize y power 2 plus 6y plus 9 equal 9. Now, let's isolate it in the x and y. So here x power, we know that the x power 2 plus y power 2 is r, right? R power 2. So r power 2 and y equal r sine theta. So r squared equal negative 6 r sine theta. We need to isolate the r, so this means I have to divide by r. So r equal negative 6 sine theta. For those who don't know why I just convert x power 2 plus y power 2 to r power 2, this is the equation of circle. X power 2 plus y power 2 equal r squared. And also we take it from the vectors that r equals the square root of x power 2 plus y power 2, right? So if I need r power 2, it would be x power 2 plus y power 2. Question number 10, the polar equation r equal 5 secant theta is equivalent to the Cartesian coordinate 2. Okay, now you know that r or x equal r cosine theta, right? And what's the r? It's 5 secant. You know that the secant is the inverse of cosine because it's 1 over cosine. So if you multiply anything by its inverse, it give you 1. So x equal 5 because secant theta times cosine theta equal to 1. You already know about the complex number or the imaginary numbers, right? Now, I could also convert the complex number to polar form. So it's the same way. You know that the complex number is a plus b I is the imaginary number. So To convert it to the polar, I will say z equal r times cosine theta plus sine theta. Now, how could I get the r? It's just about magnitude, so I'm gonna take r equals the square root of a power 2 plus b power 2. And I need the theta, of course. To get the theta, this means I have to get the inverse of tan. So inverse of tan for b over a. I will just say just x and y. It's the same as we did before. We have also something called the Moivre's theorem. The Moivre theorem is just about if you have a complex number and you raise it to a power and you need to get the answer for it in the polar form. So here, whatever the power you have, you're gonna raise it on r and multiply it to theta. Let me give you an example to understand this. You have 1 plus root 3i to the power of 6. Now let's convert it. If I want to get the r, this means I have to square it, right? So r equal square root of 1 power 2 plus root 3 power 2. So it's root 4, which is 2. Now I need the theta. So theta is the inverse of tan for root 3 over 1. Which theta that you have the answer for it as for tan root 3? So theta is 60. Now I could write it in the polar form, right? Because I have r equal 2 and theta equals 60. So let's write it. So z equal 2 times cosine 60 plus sine 60. Now I need to apply the De Moivre's theorem on it because they said it's power 6. So it would be 2 power 6 cosine 6 times 60 plus sine 6 times 60. Six times 60 equals 360. So the cosine of 360 is 1. And the sine of 360 is 0. So 1 plus 0 give me 1. So it's 2 power 6. Now 2 power 6, it's 64. So my answer is 64. So that's why how could you convert it from the complex number to the polar form and how you apply the De Moivre theorem. Now let's practice. Question number 11, complex number 2 plus 2 root 3i in the polar form. So here's the polar form. C equal or cosine theta plus sine theta. Let's get r first. So r equals square root of 2 plus 2 root 3 power 2. So this is 4. And the radical will cancel with the root. So 4, 2 power 2, 4. 4 times 3, 12. So it's root 16. So it's 4. So I got the r was 4. Now let's get the theta. It's the inverse of tan. For 2 root 3 over 2 cancel, so it would be root 3, right? So I'm getting the inverse of tan for root 3. So theta would be 60. Good. Now let's put it in the form. So it would be 4 cosine. Of course, 60 in the radian form would be pi over 3. Pi is 180. So cosine pi over 3 plus sine pi over 3. Where's my answer? Here's it. And you have to add I to it here. Hope that's ice for you. So where's my answer? Here's my answer. The argument angle of the complex number, he needs the angle. It's so obvious. Pi over 6, pi over 6 mean it's 180 over 6, so it's 30. The complex number in the rectangular or Cartesian form. So he wants me to convert it to the Cartesian form. Give it to me in polar, and I'm going to convert it to Cartesian. I need A and B. So A here is R cosine theta, and B here is R sine theta. It's the same. Let's apply it. So R is 6 and cosine 30. So 6 times root 3 over 2. So it would be 3 root 3. And 6 times half, it's 3. So here it would be 3 root 3 plus 3i. Question number 13, he's giving you here two polar complex numbers, and he asking you to get the product. It's so easy. You just multiply the radius and you're adding their angles. So let's do it here. So it would be here, z1 times z2 equal 3 times 4 times cosine theta over 4 plus theta over 6. If you are multiplying, you add the angle. If you are subtracting, if you are dividing, you subtract the angles. So here it would be, if I want to make a common denominator here, it would be 12. So this would be 3 pi, and this would be 2 pi. So if I add, it would be 5 pi. So it's cosine 5 pi over 12 plus sine 5 pi over 12. 3 times 4 is 12. So cosine 5 pi over 12 plus sine 5 pi over 12. Here's the answer. Again, if you are getting the product, you add the angles. If you are dividing, you subtract the angles. That's it. Here's asking you to divide. So divide the radius and subtract their angles. That's it. So it would be here 2 times cosine 270 minus 120, 150. Sine 150. Where's my answer? Here's it. The value of the expression 1 minus I root 3 power 6. So here is a complex number raised to the power. So this means I have to apply the De Moivre theorem. So let's convert it first to the polar form. Let's get the R. So it's root 4 times, this is 2. Now let's get the theta. It's the inverse of tan for b over a, so negative root 3 over 1. So this is give me 120 or negative 60. So theta here is 120 or negative 60, and I prefer to use negative 60. It's more easier in calculations. So here, it's okay. Now let's apply the De Moivre theorem. So z here equal 2 times cosine negative 60 plus sine negative 60. I need to raise to the power of 6. So z power 6 would be 2 power 6 cosine negative 60 times 6 plus sine negative 60 times 6. So here, the cosine of 360 is 1, and the sine of 360 here is 0. So 2 power 6 give me 64. Question 17, he made it easy for you. He gave it to you in the polar form. And he's asking you just to apply the De Moivre's theorem. So let's apply it. So it would be 3 power 3 cosine pi over 3 times 3 plus I sine pi over 3 times 3. This would be 27, and this would be cosine 3 cosine pi plus I sine pi. Now, cosine pi is negative, pi is 180. Okay, so cosine pi is negative 1, and sine pi is 0. So here is 0. So it's 27 multiplied by negative 1 give me negative 27. Here is the last rule that we're going to take it for this chapter, how to get the distinguished root for any complex number in the polar form. I have here a complex number represented in the polar form. R is the modulus, and theta is the argument. This is the mathematical expression for that, okay? Now, do you remember when I told you if we have R and theta, I could represent them in many ways. According, how could I change the theta, add or subtract 360, or its multiple, or change the direction of the R and change and add or subtract 180 and its multiples, right? So what do you think if I change the representation of the theta, does this change also how I could get the root? Of course, yes. So do you remember when I told you, مثلا, for example, take the square root of 4, you got positive or negative 2. You got two roots, right? So let's try here to apply whatever you understand on the complex numbers. So according to how you're gonna change the theta, you're gonna have distinct root. But is it going forever, or we have some limits? If I want to take the square root, so this means that n would be 2. So it would be cosine theta plus 2k pi over n plus I sine theta plus 2k pi over n. I'm going to explain it now. So this means n here would be 2. And here is the theta that you won't know. You already know, okay? And maybe you're gonna make a different representation of theta, so you're gonna add or subtract 360 or one or more rotation for it. So here is 2 pi, this is the 360, and k is how many you're gonna repeat this rotation. So if I want the square root, so n would be 2, and k would be 0 and 1. Okay, now what if n equals to k? Now, if I put k here with 2, actually you're gonna repeat the roots. Now, no more distinct root again. So here, according to the number of roots that you want to know, the k would be less than it by 1. Okay, so here n equal to, so k may be 0 or 1, whatever you need to take the cubic root. So n equals 3. So this means that k would be 0 or 1 or 2. And once n equal to k, this means I'm gonna repeat the roots. No more distinct root. Now, question 18, the modulus of the principal cube root of the complex numbers. The modulus is the r, right? And he's asking you, I'm taking the cube root. So this means I'm gonna take the cubic root of 27, so it's 3. Modulus means the radius. Okay, here, question 19, when finding the second root of the number 1, the fourth root is. Okay, let's try to write the rule and to apply it step by step. Okay, that's good. Now let's see if we know all of the variables here. Okay, do you know the R? Yes, he told me I need to take the square root of the number 1. So R is 1. Okay, good. Theta, all the time we regard theta as 0. But if he specified another angle, you're gonna put it. So theta here is 0. Okay, N is 6. Good. What about K? He told me I need the fourth root. Okay, good. And N is 6. So this means maybe K is 0, 1, 2, 3, 4, and 5. And if I need to take the first root, this means that K is 3. You just subtract 1. Okay, good. So we know all the variables now. We could just substitute it and get the answer. Let's get the answer. Here it would be square root of 1, the 6th root of 1, multiplied by cosine 0 plus 2 times 3 times pi over, let me make it in small handwriting. So here it would be 1 and 2 times 3 is 6. 6 cancelled with 6, so it's 0 is cosine pi. And here's also would be I sine pi. So where's my answer? Here's my answer. Now, the value of the expression 2 root 3 plus 2i to the power of 3. So this means I have to put it in the first in the polar form. So let's put it. Let's get the r first. It would be 2 root 3 power 2 plus 2 power 2. So here 2 power 2 is 4 and root 3 power 2 is 3. So 4 times 3, 12. 12 plus 4 give me root 16. So this is 4. Let's get the theta, the inverse of tan, for 2 over 2 root 3. So it's the inverse tan 4. Cancelled. 1 over root 3. So which theta has the tan of it? 1 over root 3. So its theta is 30. Let's write it. So it would be, so r is 4 and theta is 30. Now let's apply the De Moivre's theorem and raise it to the power of 3. So z power 3 give you 4 power 3 times cosine 30 times 3 plus I sine 30 times 3. So here 4 power 3 is 64 and cosine 90 is 0. This would be 0. And sine 90 is 1. So 0 plus 1, I. Don't forget the I, so it's 1i. So here it would be 1i times 1i, so it's 64i.